Yeah, so you're at the talk, how to render 20,000 rows without crashing Chrome. And let's get started. So I'll dive right in. So a little bit about me before we start. My name is Lydia. I'm a software developer at Atomic Object, which is a company where we build custom software for a wide range of customers. And today I'm here to tell you a story. I'm going to tell you a story about how I crashed Chrome. So the project I was working on had thousands of rows of data that we needed to render in Chrome. And I was experimenting with how to make a scrollable table that showed all those thousands of rows of data. In one of my first attempts, I was storing all those rows in client-side memory, and Chrome ran out of memory and subsequently crashed. I think we can all agree that we would prefer not to crash Chrome. So this talk is about how to not do that, and it's about how to instead load and display huge amounts of data and still have a really snappy user interface. So in this talk, I'm going to go over kind of 3 points of things to watch out for when you want to implement a really snappy, just-in-time data loading table. So the first point I'm going to look at is what you can do on the front end to have really good performance. So on the front end, I'm going to talk about how you can only render the elements that the user will see, so how you can virtualize your data, and also talk about only re-rendering elements when necessary. So this will help the table to have snappy performance on the front end. Next, I'll talk about how when you fetch the data for the table, you can fetch the data incrementally, so use just-in-time data loading. And lastly, how in order to do just-in-time data loading, how you can have a backend that supports pagination. Throughout this talk, I'm going to be using this little example that I built. This example is a very simplified table that does just-in-time data loading. On the front end, it uses React and Apollo client. And on the back end, in this example application I built, it uses Node and GraphQL and a pSQL database. But a lot of the concepts that I talk about on the back end, I won't get very tech stack specific, and I'll try to keep it much higher level. So whereas on the front end, I'll be talking a little bit more about React specific libraries and performance optimizations. On the back end, I'll keep it pretty high level. So whatever type of web app you're using, whatever kind of API you're using, even if you're using a REST API, hopefully this talk is still relevant. So let's dive right in to the front end performance. So on the front end, in order to have better performance, we want to only render the rows that the user will see, and we want to not unnecessarily re-render components. So one way I like to think about this is when I think about shopping. So when I go clothes shopping in the dressing rooms, I can only take 4 items into the dressing room with me at one time. So I might have 10 items in my hand or in my cart, and then I take 4 items into the dressing room, try on those 4 items, then take another 4 items into the dressing room, try on those 4 items. So instead of bringing everything in all at once, I only bring in the number of items I can easily try on. When I'm doing this, I'm basically virtualizing my clothes. So instead of trying everything on at once, I'm trying on a subsection of what's in my cart, then trying on the next subsection of what's in my cart. This isn't too different from what we want to do on the front end. So similarly, if I'm virtualizing a list, it means that I don't want to render all my elements at once. Instead, I want to render only enough elements to fill the screen that I'm currently looking at. And rendering only enough elements to fill the screen that you're currently looking at is called virtualizing or windowing your data. And it has a couple advantages. So if I only render enough rows to fill the screen, it means when I initially load the page, I'm going to be doing a lot less rendering work. And it also means when I initially load the page, I'm going to have a lot less of these DOM nodes in memory. So as the user scrolls up and down, I'm going to have a lot less things in memory, so a lot faster performance. So if I look at this example, you can see, say, I have rows 1 through 7 that I might want to be showing on the page. When the user initially loads the page, I'll only have rows 1 through 5 in memory. And then when the user scrolls down, I'll have rows 3 through 7 in memory. So I'm not having more rows than I need in memory at any given time. So let's talk about this in the context of this example. So if I let me make this full screen for a second. So if I look at the elements on this page, you can see here that I have a lot of divs, but all the divs that I have on the page, all the divs that I see here are divs that are actually on the page. So it's not the case that I have a whole bunch of hidden divs at the bottom of the page that are on the page, but I can't see. I'm only rendering the divs that the user can see at any given time. And then when I scroll down, you can see this is changing a little bit. And this means that the old divs are falling off the page and being replaced with the new divs. So basically, I'm virtualizing the data. I'm only ever showing the number of divs that I want to be showing on the page. So that's one thing I keep in mind when implementing the front end for just-in-time data loading is when I'm actually rendering the data, only render enough rows to easily fill the viewport. Another thing to keep in mind is not unnecessarily re-rendering components. So if I want to have a snappy table, one thing that's important is that I'm not rendering rows more than necessary. So how do we tell how often, like as I scroll through this list, how often these rows are re-rendering? There's a tool, if you're using React on the front end, which we are using, there's a tool, the React Profiler. So if I go to Profiler, and then I'm going to click Record or Start Profiling, and I just scroll around, and then I click Stop Profiling. And so here, let me make this a little bit bigger so we can actually see it. Okay. Oops. Oh. Okay. We'll try that once again. Okay. I'm going to press this, start recording, press this, stop recording. Okay. So these are all the things, all the parts of the page that have been rendered. So basically React Profiler will, whenever I render a component, if the component has to re-render, it will show up as gray in React Profiler. And if the component has, if the component renders, it shows up as colored in the React Profiler, but if the component has already rendered, it shows up as gray in React Profile. I think the thing that happened here is that I already loaded this page and have scrolled around in it. So most of these components have already been rendered, which is why most of them are gray. But we use this React Profiler to ensure that we're not re-rendering these columns and rows more than we need to. So one thing that was important to us when we implemented this is when we scroll up and down, for instance, we don't want this row to render once while it's in the middle of the screen, and then when you scroll up to render again when it's on the top of the screen. We want it only ever to render once until it scrolls out of view. So kind of going back to the slides, if I'm showing rows 2 to 4 in the viewport, when I scroll down, I want row 3, for instance, to not re-render just because it changed where in the page it was. So in order to do that, we had to make sure that we were being really careful about applying memoization functions. So making sure that we weren't entirely re-rendering the component whenever its absolute position on the page changed. So those were kind of two things we were keeping in mind for front-end performance considerations. So I kind of talked about the things that we kept in mind on the front end. So how do we implement it? What kind of solution did we find that let us only render what we wanted to on the screen, and also helped us not unnecessarily re-render components? We use a library called React Window. And this library does a lot of the work for you. Basically, you just need to know how to use this library, and then it will take care of a lot of the virtualization for you. We still had to worry about the memoization and not unnecessarily re-rendering components. So the way React Window works is it provides you a component. Either you can use a list component or a grid component. So the list component renders the rows necessary to fill itself based on your horizontal scroll position. So basically it lets you window vertically, whereas the grid renders the cells to fill itself based on your vertical and horizontal scroll position. So this means that using the grid component lets you window both vertically and horizontally. Let's get into a little bit more of the nitty-gritty of this. So I'll actually show you a grid component and how we set up a grid component. So if I dive into the code, let me X this out. So this is a grid component, and we're using this grid component from the React Window library. You provided some basic configuration, so the height of your grid, the width of your grid, what you want the height of a given row to be, stuff like that. And then the two most important things that you provided is, first off, you provided a callback. So whenever you scroll around in the grid, you are going to get information about what section of the grid was rendered. And then it's up to you to have a callback that then takes that information about what section of the grid was rendered and does something with it. And then this fixed grid component will invoke that callback whenever you scroll around the grid. So right now, in that callback, I'm not doing too much. I have a console log that just logs the grid information whenever you scroll around. So if we look at our console, and maybe we make this a big screen again. And then if I clear this, and if I scroll around, you can see this is the information about where in the grid I am. So as I scroll down, the row index is getting bigger. As I scroll back, the row index is getting smaller. As I scroll to the right and to the left and up and down, I get these console logs that tell me, that basically provide information about the current section of the grid I'm in, and we'll use this callback later. We'll hook that up to the infinite loader so that as we scroll around the grid, we can give information to the component that's wrapping the grid about where in the grid we are. But for now, we can just remember that we have this callback and we can provide the grid a callback where we do whatever we want with the information about where in the grid we are. So that's one thing that we provide to the grid component. The other thing that we could provide to the grid component is a render prop. So this is a child component that takes some information. So it takes the absolute position, the row index, and the column index, and then it lets you determine what you want to render with that information. So I think a good way to understand this again is for us to poke around with it. So right now, this component takes a row index, a column index, and style, which is the absolute position. And right now it's returning this thing that indexes into some data we have client side and renders the contents of this cell. But what if instead of that, what if we just returned a div that said hello? What would happen? So as you see here, we just have a bunch of cells that they've lost their position information because we're no longer applying the styling, and they're stuck to the left of the page. So let's fix that. Let's at least make it so that they're in the correct place. So this grid component, one of the things that it provides us is the style object, and then that provides the absolute positioning so that the cells actually show up in the right place in the page. So let's apply the style. So now at least our cells are in the right place in the page. And then, as I mentioned, the other two things that we're given here when we determine what to render for a specific cell is the row index and the column index. So let's just print out the row index. So I'm going to say maybe R, and then I'm going to say row index. I'm going to say C, and I'm going to say column index. So now, oh, my bad. So R, and then row index, C, column index. Okay. So now we can see the row index and the column index. So as we scroll around the grid, we see, okay, this is row 14, row 15, row 16. But that's, I think we can agree that this isn't super helpful. We have a grid with a bunch of cells, and each of the cells just have the row index and the column index on them. What we really want to be able to do is we want to be able to use that row index and that column index to index into some data and figure out what we should be displaying at that specific row and that specific column in the table. So that's how my demo application is hooked up. So in this demo application, it goes through a couple levels to get that thing, but under the hood, this is basically going up a level, calling a function that function uses a transformer to basically take some data we have client side and figure out, given this row index and this column index, what data should I be rendering at that for that specific row and column. But in order to do that, we have to have that data that we want to index client side. So that brings us to the next part of the talk, which is how do we get that data that we need so that then client side, when we have a row index and a column index, then we can basically index into that data and render the thing that we want to render. So let's talk about close shopping again for a moment. So last time we were talking about shopping, we were talking about a dressing room and how you could only bring 4 items into the dressing room at once. So you put 10 items in your cart, and then you try them on 4 at a time. But say you want to find the perfect zoomed top. So instead of just trying on 10 items, you want to try on 100 items. But you won't want to put all 100 items in your cart at once and then bring those all to the dressing room at once because you wouldn't want to look like the person in this picture. And your cart might not even be big enough to hold all 100 items. Instead, you would want to go to the store and then pick 10 items to put in your cart, try those items on 4x4, and then put another 10 items in your cart, try those items on 4x4. And that's basically what just-in-time data loading is. So you want to be able to fetch things in chunks, like in groups of 10, instead of all at once. And just like you won't want to fetch all 100 items of clothing at once, you won't want to fetch all your data from the server at once. Even like however good front-end performance you have, it might even just not be possible. So instead of fetching all the data from the server at once, you want to just in time load your data. So you would want to fetch a chunk of rows. So you say fetch 5 or 10 rows from the server. In actuality, in most applications, web applications, it's probably more like 100, 200. And then you render those rows. And then when the user scrolls down far enough, then you fetch another chunk of rows. So looking at this example, where on the client, the user scrolls down, then the client goes to the server, asks for 5 rows. The server gives the client rows 0 to 4. Then the client says, okay, great. But then the user scrolls down again. The client requests from the server more rows, gets more rows back. So basically just in time data loading. And this might even be necessary. So for some applications, you couldn't even get the application to work without using just-in-time data loading if you have like 10,000 rows of data. And this is actually kind of where the title of the talk comes in. So in one of my first attempts at implementing this scrollable grid, I was doing some things right. I was doing virtualization client side. I was incrementally fetching data from the server, but when I was fetching the data from the server, I was storing all the data that I had fetched from the server in memory client side and never cleaning out my application memory. So basically, as the user scrolled down, there became more and more data in application memory, which caused Chrome to crash. So from that, I learned that without using just-in-time data loading correctly and without having some way to clean up application memory as the user scrolls down the list, it might not even be possible to render however many rows that you want if you're working with a huge enterprise with tens of thousands of rows about their products. So that's kind of the broad level of just-in-time data loading and why we need it. Again, I'm going to jump in a little bit to the nitty-gritty of how we did this using our specific tech stack. So if we go back over to the code, so this is our grid component that we talked about previously. And as you can see, the grid component is wrapped in this infinite loader component. So infinite loader is another library that is designed to incrementally fetch data, and it hooks in really well with React Windows grid and list components. This component takes a couple props. So it takes this prop is item loaded that given a row index, so say if I was at row 5, this function would say, is row 5 loaded or not? So this callback needs to be able to determine, given a row index, have I loaded the data I need for that row index or not? Which this function is pretty easy to implement. Basically, you just check if you have that row in client-side memory. If you do, it returns true. Otherwise, it returns false. Another callback you need to provide when you're using infinite loader is a callback that knows how to load more rows if necessary. So if I scroll down to the list, in the list to say row 20, but I hadn't yet loaded the data that I needed for row 20, then infinite loader under the hood would call my load more items callback, and then that would be responsible for going and getting more data from the server. And then one other thing that you provide to this infinite loader component is this render prop. This render prop takes 2 arguments, the on items rendered and ref, and it's responsible for, given those 2 arguments, rendering something that invokes this on items rendered callback whenever the user is rendering whenever the thing that the user is rendering changes. So for instance, whenever the user scrolls up and down the grid and they're at a new spot on the grid, then this render prop would be responsible for invoking the on items rendered callback. And when infinite loader has its on items rendered callback invoked, then it will be like, oh, okay, the user scrolled down to say row 20, then it will call its is item loaded function and say, do I have the data I need to render the data, do I have the data I need for row 20? If the answer is no, then it will invoke, infinite loader will invoke the load more items function, which goes and gets more data. So basically, kind of in summary of how these 2 components work together, the grid component is responsible for, given a row index and a column index, figuring out what to render. But it can only render the thing if it has the data. So that's why we hook it into infinite loader. So if it doesn't have the data, then it calls infinite loader to go and fetch the data. So infinite loader is basically the component that has to go and figure out how to fetch the data if we don't have the data. And this is in the load more items callback where we have to provide a way to get more data from the server. So that leads us to our third point. We have to have a backend that supports pagination if we want to be able to do just-in-time data loading. So let's go back to the clothing store for a minute. So we're talking about how you would want to have multiple cartfuls of 10 items instead of one cartful of 100 items. So where do you get these cartfuls of items from? You get them from walking around the store. You pick up the items you like from the rack and you put them in the cart. If the racks didn't exist, you won't be able to gather that cartful of clothes. So where do the clothes in your cart come from? They come from the store. So the store has all the clothes. You put a subset of clothes in your cart, and then you try those clothes on in even smaller batches. So that's basically what we are doing in our server. So just like the store where you go to get the subset of clothes you want to try on, the server is where you go to get that subset of rows you want to render. And that subset of rows or group of rows can also be called a page of rows. And pagination, like pages in a book, separates the data into pages. And there's a couple of different ways to implement pagination. Two of the main types are offset-based pagination and cursor-based pagination. So offset-based pagination is where the client, say, asks for count number of rows starting from an offset. So for example, the client would say, give me 10 rows starting from offset 0. Then you would go to the server, get rows 0 to 9, return those to the client. Then the client would say, okay, give me 10 rows starting from offset 10. And then you would get rows 10 through 19 from the server. And then you would ask for rows starting from offset 20, etc. You get the idea. So in offset-based pagination, you basically have an index that you use to get the number of rows that you want. In cursor-based pagination, instead of asking the GraphQL server or whatever type of backend you're using really for a count number of rows starting from offset, instead you ask for count number of rows starting from a cursor, where the cursor is a unique identifier for a specific record. So let's look at this in this current slide example. So the first request from the client would be, hey, can I get 10 rows, please? But I don't have a start cursor yet. So then you go to the server, and the server would return 5 rows. And these 5 rows would be the first 5 rows that you had because you don't have a start cursor yet. And along with those 5 rows, the server would return some information about those rows. So the server would return the start cursor, which is the cursor that is the unique identifier for the first record that you return. And it also returned the end cursor. And the end cursor is the cursor for the record right after the last record that you returned. So in this example, the cursor is this end cursor is the cursor for the row that would come right after 4. And now that you have this end cursor, you can use your end cursor to ask for the next chunk of rows. So then you can go to the server again, and you can say, okay, I want another 5 rows, please, but my start cursor is now F. And then the server will use that start cursor to figure out what the next chunk of rows to give you is. It's almost like, I like to think of it as a linked list and having a pointer in a linked list and saying, here's my pointer, go this many nodes forward. So GraphQL docs recommend cursor-based pagination for a couple reasons. One reason is it can be more efficient than offset-based pagination. And another reason is if you're inserting and removing a lot of data from your database, it can be more accurate and you'll be less likely to have skipped records. So I can post some resources post this talk. It's a pretty deep topic about how these different pagination methods work, but that's the kind of general overview of what those two pagination methods are and why you might use one versus the other. Because the reason you would use offset-based pagination is often if you want to do a lot of sorting, offset-based pagination could be a better fit. So for the rest of this talk, I'm just going to assume that we're going with cursor-based pagination. And if you are using cursor-based pagination, you have to have a cursor, which is a unique identifier for your record. So in this example, like our cursor for 1 was B, our cursor for 2 was C. So you have to somehow be able to come up with a unique identifier for the row that you're returning. And your cursor must be sequential, and it must be something that you're willing to sort by. So when I implemented this little example, I used if we look back at this example, there's a date right here, which is the date that the date time, I guess, which is the date time that the record was created. And that's an attribute of the employee. So I used the created at column to be the cursor for each employee row that I return. So this kind of like the unique identifier, the way I figure out which row I'm talking about. So kind of going over what we want the shape of our backend to look like, because I'm not going to go into the nitty gritty of how I implemented it in GraphQL, but the general shape of the backend was given a count and a start cursor. I wanted the GraphQL server to return the number of rows that I asked for. So if I asked for 10 rows, I wanted to get back 10 rows, starting from that start cursor. And I also wanted to get back some information about the chunk of rows returned. So I wanted to be able to know if I had reached the end of the chunk of rows or if there is more rows to query after that, because on the front end, basically, I want to be able to know, like, should I keep trying to fetch data from the client, or is that all the data there is, and I should just show the end of the list? And then I also wanted to know what the start cursor was and the end cursor was of the chunk of rows that was returned. The most important of those being the end cursor, because then the end cursor is kind of your pointer you use to fetch the next chunk of rows. So how do I get this information? How do I get the next chunk of rows and the start cursor and the end cursor, and how do I know whether I've reached the end of the list or not? So depending on what tech stack you're using, there's probably different ways that you go from your API to the database. But essentially, you're going to have to make your way to the database, and you're going to want to ask the database this question. You're going to want to say, give me up to count number of rows where the created at value is equal to or larger than the cursor. And for us, we're using the created at value because that's what I decided to use as the cursor. So then when we translate that into SQL, we basically say, go to the employee table and then order by the cursor and select limit and basically get count number of rows where the created at date for the employee is greater than or equal to your start cursor. So that works great if you have a start cursor. If you don't have a start cursor, we just say select the count number of rows from the employee table, order by the created at date. So that'll just give you the first 10 rows with the lowest created at value, essentially. And then the next time you query it, you'll have a cursor. So then you can actually start getting the rows starting at the created at date that you supplied. So at the database level, I created a function that takes a count and optionally takes a created at start cursor. If I have a created at start cursor, it uses the first function or uses the first query here. If I don't have a created at start cursor, it uses the second query here. So those queries are what I used to get the things that I needed from the database. Now all I had to do was map the results of the database back to some response that we could return to the client. In my case, I was using a GraphQL API, so I did this work on a resolver. but I'm sure this work could be done in a different place if you're using a different tech stack. So I got the rows from the database, and if the user asks for count number of rows, I asked the database for count plus 1 number of rows. Then I returned the count number of rows back to the user. And then I also returned information about the chunk of rows. So I used that extra row that I fetched to determine if we had reached the end or if there's more rows after the current row is returning. And I returned the start cursor, which is just the created at date for the first row, and the end cursor, which is just the created at date for the last row. So let's circle back to a moment to just-in-time data loading and how we're going to use this data that we fetch from the server on the client. So if you recall, when we scroll around the grid, for each row we're going to invoke this isItem_loaded method. If that returns false, we're going to invoke this load more items callback, that's then going to go to the server, and it's going to ask for more items. So the first time we load the page, we're not going to have any items loaded yet. So our start cursor is going to be undefined. And say that we want to fetch our rows in chunks of 10. Then we would go to the server and we would say, I don't have a start cursor yet, but could I please get 10 rows? Then the server is going to, under the hood, go to the database, look up what it needs, and then return to the client the 10 rows, but also it's going to return some page information. Most importantly, it's going to return an end cursor. Then it's up to the client to take that information and store that row in client-side, those rows in client-side memory, and store that end cursor in client-side memory, because we're going to need that end cursor to make our next request to get the next chunk of rows. The one thing to be careful for here, though, is that if you always just keep storing all those rows in client-side memory, eventually you could use up all your client-side memory. So what we used on our application was Apollo Client, and Apollo Client does a lot of the management of memory for you on your client-side application, and it even lets you manage if you get a response from one GraphQL query, and then down here when you make another query and fetch more rows, it can help you manage basically zipping those two responses together. But whatever solution you use client-side, you'll have to basically store some state client-side, because you'll want to store some of the rows client-side, and you'll always need to store that end cursor client-side so that you can make another request with that end cursor, so you have that pointer to get the next chunk of rows. But the one thing you want to be careful for is to make sure that you're not storing so much in client-side memory that you crash program. So going back to this example, we went to the server, we got the first 10 rows, and then in response, we got an end cursor and some rows, and we're storing those in client-side memory. But then the user scrolls down the grid a little bit more, and because the user scrolled down the grid a little bit more, so if I say I had loaded the first 10 rows, and then I scroll down and I hadn't yet loaded the row here, you can see that if I scroll down quickly, I think most of it's loaded in client-side memory right now. But you can see there's like white for a second, and that's when it's going to the server and loading the next chunk of rows. So then we say, okay, I need to load another 10 rows. We go to the server. The server uses the start cursor that you provide, which the start cursor corresponds to your previous end cursor, so you get the next chunk. And then it returns the new rows along with the new end cursor. But then you can overwrite your end cursor in your client-side memory with the new end cursor, and then add those new rows to your existing rows up to a point, but then eventually you'll have to get rid of those old rows so that you have room for your new rows. So overall, when we kept these three things in mind, we had success because we did not crash Chrome. Going back to this example, as you scroll around, we're only rendering the amount of DOM nodes that fit on the page, and we're not unnecessarily re-rendering each of these cells because we have a good memoization function. We don't load all the data that you would want to see at once. Instead, we're using just-in-time data loading. And we're client side, we're managing our state so that we store some things in our state, but we're also making sure that we don't keep our state around so much and never like recycle our space so much that we crash Chrome. For us, we're using Apollo client to do this. And we have a backend that efficiently supports pagination. For us, we use cursor-based pagination, meaning that we can quickly ask for the next chunk of data and get a response. So that's about all I have for today. Next time you go clothes shopping and you take a couple items into the dressing room with you, you can think about virtualization and how rendering just a few items at a time makes for a lot snappier front-end performance. When you fill your cart with an armful of clothes, instead of trying to shove 100 items into your cart at once, you can think about the client loading data from the server incrementally instead of trying to load everything all at once. And as you walk around the store trying to figure out what the next 10 items you should put into your cart are without wasting too much time, you can think about that backend that supports just-in-time data loading in a really efficient manner with cursor-based pagination. Or you can just enjoy clothes shopping and think about this all later. These are my images. And this topic has a lot to cover, and I'm aware that I went over it very quickly just because the full stack implementation of just-in-time data loading has a lot of areas where you could go much more in depth, from front-end performance to different ways of pagination, say offset-based pagination versus cursor-based pagination. I wrote some blog posts about these. I have a 5-part blog post series where I discuss this in much more depth, and I provide specific technical examples. So if you are actually to want to try to implement any of this, I would recommend that, because just the information you got from this talk is, I'd say, a little bit higher level. So here's a link to the blog post if you would like to look into any of that. And here's my email. I'm also happy to provide, I'm planning after this talk to link these slides, and I can also link some of the resources that I found really helpful when learning about different types of pagination and React performance on the front end for just-in-time data loading. I would love to answer any questions if anyone has any questions.
Yeah, feel free to unmute yourself and ask a question, or submit your question through the Q&A area in Whova. There was a question that was posted ahead of time before the session started. Do you have any articles or tutorials to read or prepare for?
Yeah, so I think some of the articles I found really helpful, and I can link these. I don't know if this is something I could send to you or link on the talk afterwards, but one of the articles I found really helpful was on Medium. It compared offset-based pagination versus cursor-based pagination and went in depth in that. Another resource I found really helpful is if you Google React profiler, like performance video or something like that. There's someone, the founder, the creator of React Window has created some really good YouTube videos on basically being able to measure the performance of, say, in this one specific example, it would have been the table. And Profiler, I couldn't get to work exactly how I wanted to when I was giving that really quick demo, but it's a really useful tool for figuring out how much things are re-rendering as you scroll around the page. So I'd say look up those two resources, if you Google React Profiler performance video, or if you Google around a Medium for offset-based pagination, you can probably find those things, but I'll also can link those things after this talk.